Welcome back, class. Thanks for tuning in. Thanks for all those who are actively volunteering to do some of these activities each week. I really appreciate it. It's definitely going to help you in the long run for next year. But again, this is a far distant second place in priorities compared to your health. Take care of each other, stay safe, stay healthy. But again, I'm hoping that if you find some time where you're kind of bored and you want to continue your education, maybe it's something you want to do, kind of providing these activities each week, and hopefully you're finding them useful, and hopefully you're kind of following along each week. But again, appreciate those who are trying. I can definitely tell you that. So let's jump right into the iPad and let's kind of look at kind of their topic this week. All right, so what we're in week 5, part 3, and so this going over the Google form from Monday, and so we're doing systems, right? That was our priority. That was something that's new / kind of review if you had an algebra 1 or geometry a little bit. And so the methods we're using are substitution and elimination. I'm going to try to avoid graphical. I don't think I want to do graphing. I know in algebra 1 you graphed a lot, and so I want to kind of stick with methods you can just do with pen and paper. That's kind of the idea. But again, a system is where there's two equations and there's one common solution between them. Hopefully a common solution. It could be an infinite or no solution, but we're trying to find one answer that works in both. And these could be story problems. It could be, just maybe you're just looking at, data sets in your business and you want to see where they cross, profits and losses. So that's what we're going to look at. We had 5 problems on the Google form, and we're going to kind of go through each one here. I'll try to kind of bounce back between one form to the other form in terms of methods. So I'm not just sticking with the same method every time. So if there's an easy way to do it, I'll pick the easiest way. But again, hopefully that works for you and you can kind of see different methods of doing it. But we're looking for common solutions. So all right, let's jump right into the first one here. So on this particular problem, I'm probably going to use substitution. Now the reason why I'm going to do that is because it looks like it's kind of easy in the back equation, x plus y equals 5. That looks like it's probably the easiest. So I'm going to solve that one for y. So what I'm going to do here is I'm going to move that x over and subtract it across. I'm going to move this x over. And now why I'm going to do that is I'm going to substitute this 5 minus x into the other equation, this first equation, in for the y. Y is a 5 minus x because they're going to be the same answers in both. So I'm taking out, make sure I write down the problem correct. I'm going to take out the y and replace it with a 5 minus x. This is substitution. That's a substitution method. You're substituting one equation in for the other for one variable. That way in this problem, this is now just a simple algebra 1 problem. It has one variable, and all we have to do is solve. And that's kind of the easiest process for doing this one. And it will give us the x answer, obviously, because that's the only variable left. So I'm going to distribute the 3 into this parenthesis because we still have to follow the rules for normal distribution. So that's 15 minus 3x equals 9. I'm going to move the 15 across the equal sign. So following the rules of algebra, that has to subtract across. It always changes sign when it moves across an equal sign. And the 2x minus 3x is on this left side. So that would be a negative 1x, 2 minus 3. And then on the other side, what is that, a negative 6 on that side? And I can divide both sides by negative 1. Or just get rid of the negative sign, if you will. So my x is 6. So there's my answer that works in both equations. Now what I have to do is I have to go take this 6 and go plug it back into one of the 2 originals. So I'm going to switch up my color here. And I'm going to plug this 6 back into one of the 2 equations in the beginning. I'm going to use the second equation. I think this is the easier of the 2 equations that we were first given. And I'm going to plug this 6 in for the x. And so, by substituting that in, it looks like just common sense. My y has to be a negative 1. Now, why I know that is because 6 plus a negative 1 makes 5. And this would be the answer for both. So the coordinate that works is 6 comma negative 1. That's my x, that's my y in terms of like alphabetical order. And this is kind of the idea. That's what I'm looking for. I'm looking for an ordered pair that works for both. All right, so that was substitution method. And again, if you would have done elimination method, you would have got the same results for these 2 equations. All right, so going to this one, I'm going to do a different method. I'm not going to do that same method like substitution. I could give me the answers for this one, but let's try to go through and maybe we'll do elimination method on this one so you can see different forms. All right, so elimination method is when you stack the 2 equations on top of each other, like this. That's the elimination method. And you pick one of the letters. So I'm going to just pick X's. They already have 1s. That's perfect. They're already the same digit. I want to make them opposites because they're not already opposites to begin with. So I'm going to make the top row negative because I want the X's, the letter I chose, to be opposites. And if they're already opposites, you don't have to do this step. But now that they're opposites, I can add straight down. So if I add straight down, the X's literally cancel to make 0. There's no X's anymore. That's eliminated itself. That's why it's called elimination method. Then I have the -1 plus 2. That makes 1y. So 2 minus 1, basically. And then the 11 and the -7, when I add those together, I'm left with 4. And so if I divide both sides by 1, or just get rid of the 1 in general, my y is a 4. So there's my first answer. And now what I'm going to do is I'm going to go plug that back in. I'm going to pick one of the two equations. I'm going to pick this first equation that looks like the easiest one out of the two. And I'm going to plug my 4 in for the y, because it literally says y is a 4. So I'm going to plug that in. And so it looks like, by common sense, my x has to be a 3. There we go. And so there's my solutions. Now if I write this as an ordered pair, again, alphabetical order, x, y, that's the answer that works for both. If I plug 3 and 4 into both equations, it should give me the same answers in both. All right, let's go through. We got, what, 3 more problems to go here? 4, 5, and 6. This one, I'm going to do elimination method again. Now, what's telling me to do that is because there's no x by itself. There's no y by itself. Each of these have variables and numbers in front. And the fact this one has a decimal, so it could be a decimal for my final answer. But let's kind of work through this one here. Switch up my colors. So let's stack these two equations on top of each other. Alright, so here's my first equation. Let's go to my second equation. 3x plus 3y equals 16.5. Okay. Now, I need to pick one of the letters. It doesn't matter which letter I pick, I just have to pick one of them. I'm going to pick, let's pick the y's in this case. I'm going to pick this. It doesn't matter which one I picked, I just picked y's in this case. I want to make them the same number. So I can make the y's both 6s, I can make them both 18s, 12s, it really doesn't matter, I can make them anything I want. I'm going to make them both 6s. So the top row, I'm going to leave it alone. The reason why? It already has a 6. The bottom row, I'm going to use a different color here, I'm going to multiply everything by 2. Y 2, I want to make the y a 6. So by multiplying everything by 2, I have a 6x, a 6y, and 16.5 times 2. It's a nice clean number. 16.5 times 2, 33. Alright. So now, draw a line. I want to make them opposites. So I want to make one of the rows negative. I'll make the top row negative. Because the variable I picked, the x, or the y in this case, I want to make them opposites. And I can add straight down. So I'm left with 2 x's. The y's literally cancel out, they're gone. And on the other side, I'm left with, what, 5. And so it looks like my x, if I divide by 2, it looks like my x is a 2.5. There's my first answer. And now what I'm going to do is I'm going to take that answer and plug it back into one of my other equations. So I'm going to go back to the original equations. I'm just going to pick the first one. It really doesn't matter at all which one you pick. There's my first equation, and I'm going to plug my x back in. So my x happens to be a 2.5. 2.5 plus 6y equals 28. And now I have to actually do some math here. It's not apparent like the last ones. The last ones were kind of easy. So I'm going to take 4. So 4 times 2.5, I'm left with 10, plus 6y equals 28. So it looks like all the numbers are going to work out nice and pretty on this one. So I'm going to subtract this 10 across. I'm left with 18 on that side. And I have 6y here. I'm going to divide by 6, and that gives me a 3. And there's my two answers. So 2.5 is my x, and a 3 is my y. All right, let's go to the next one. We have 2 problems left here. You can hear my dogs in the background. It's fun. All right. Okay, let's go to this one. I think I'm going to do substitution on this one. I know it seems kind of weird, but I have an x by itself. I'm going to solve this one for x. I'm going to move the 5y over. Now, it seems weird. I'm going to do that. I'm going to do substitution here. I think it's kind of important you get to see both. So I'm going to take this. This is my x. I'm going to plug that into my other equation, this one. So I'm taking out the x here, and and I'm going to plug an 8 minus 5y in for that x on that first equation. That way I only have y's in this problem. That's substitution method. Distribute the 3 here, so I'm left with 24 minus 15y minus 2y equals 7. So doing some math here, I'm kind of laughing at my dog. You can hear her snoring. He just sleeps all day. Doesn't do anything. All right. Kind of going through the problem here. I'm going to subtract the 24 crossed. So I have what? Negative 17y's. Moving that 24 over, I'm going to subtract the 24. So 7 minus 24. Negative 17. Oh, that's kind of nice. It's kind of working nice and pretty here. And so if I divide by negative 17, divide by negative 17, this turns out to be a nice clean 1. It's nice. It's really nice, actually. Plugging that back in, I'm going to pick one of the equations. I'll pick the second equation. That looks like it's probably the easiest out of them all. Plug in my 1 in for y. So if I plug in a 1 in for y, 5 times 1, that's just 5. So it looks like my x would have to be a 3. So nice easy numbers, 3 and 1. Alright, my last problem here. Absolute last one. Okay, so I could do substitution, I could do elimination. I think I'm going to do elimination here. I think that's kind of my go-to method. I'm just going to pick that one on this one. I'm going to stack the two equations on top of each other. I could do substitution. That y is by itself on that first equation. We have 4x plus 4y equals 24. Okay, so the letter I'm going to pick the x's. I want to make them both 4s, let's say. I can make them both 8s or 16s or whatever I want. I'm going to make them both 4s. So I'm going to multiply the top row by 2. So the top row by 2, 2x plus 2y equals 22. The second row, I'm going to leave this one alone. There's already a 4 in front of the x because that was the letter I picked. Alright, so that's how we do elimination, right? You pick one of the variables, you make them the same number if they're not already. And then if they're not already opposites, you want to make one of the rows negative. So I'm going to make the top row negative because I want to make them opposites. Then I can add straight down. So if you add straight down, I'm left with 0. This makes it 2y. That's a negative 2 and a 4. Add them together. And then on the other side, I'm left with a 2. So I have to divide. My y turns out to be a 1. That's kind of nice. Again, it's a nice clean 1. And now I'm going to plug that back into one of my original equations. I'm going to go to this first equation right here and solve. So it looks like my y is a 1, so I'm going to plug that in and just solve for x. So subtract the 1 across, I'm left with 10. And then my x would have to be a 5, right? Common sense. 2 times 5 is 10. And those are my two answers. Again, thanks for all those who are kind of actively participating each week. I know it's kind of tough right now. It's kind of different, but hopefully these activities and these videos I'm sending out are kind of helping you out. It's trying to keep it as normal as possible. But again, these activities are pointless without you taking care of yourself and your family. So again, first priority is being safe, being healthy, and then if you have time, you can try out some of these. Again, I know some of you are really diligently trying these activities each week, and I really appreciate that. If you're maybe doing them on paper, you're not submitting the Google forms, and again, that's your priority. It's not required. But again, if any of you are concerned about grades, just email me. I know I have a couple of people that emailed me that they want to kind of work on that. That's great. But again, take care of yourself, take care of each other, and I hope to see you guys real soon.